Hello guys, we're going to be talking about interior and exterior angles of polygons, and the first thing we want to go through is to see if we can solve this problem, and from there we can talk about interior and exterior angles of polygons. The first thing we want to do is learn what polygons actually are. Now polygons are 2D shapes, as in flat shapes that are all connected together as in a closed shape, and they all must have straight sides. So the first family of our polygon family is the triangle. And why is that? That's the minimum number of sides we can have to get a closed shape. So if I was to draw 3 lines, for example, you can clearly see I can only close that shape to become a triangle. So this is the first family of your polygon. A polygon is a flat shape, or we can call it a 2D shape, and it's a closed shape, as in everything there is closed, the edges are all connected, and it also has straight sides. Now the next family obviously is the quadrilaterals. Quadrilaterals are all 4-sided shapes. We have so many 4-sided shapes like our rhombus, kite, triangle, rectangle, square, and so on, pardon me. And you know, the next family after triangle, after our quadrilaterals, is the pentagon, which is 5-sided shape, and after that we have our hexagon and so on. So we're gonna, for the purpose of this lesson, we're gonna deal with this question, which is actually 3 pentagons that have now all been put together, and we've been asked to calculate the size of y. First thing, there are about 3 ways we can do this. So let's start with the very easy one. If I was to extend this line here, okay, this bit here, this angle here becomes the exterior angle of this pentagon here, and obviously the inside here is the interior angle. Now if you look at this polygon, if you were to walk all around this polygon, it's like you're moving in a circle, and we know angles around the point add up to 360 degrees. So any polygon in the world, the exterior angles must add up to 360 degrees. So to find out one exterior angle of this pentagon, I'm going to do 360 degrees divided by the number of sides, which is 5 sides, and this will give me 72 degrees for the exterior angle of this pentagon. So now we know angles on a straight line is 180 degrees. So if we know it's 180 degrees for both of them, it makes sense that this part here will become 180 take away 72 degrees, and this will give us 108 degrees for the interior angle. So 108, that looks like a 6. I'm going to change that to 0. This bit here is 108 degrees for the inside. Now each bit here, we've seen this is 108. That makes sense. This is going to be 108 as well, because it is a regular polygon. Now it says it here, a regular polygon is regular in the sense that the edges are all same length. Remember, this is not drawn to scale though, you know, it's not accurately drawn, so but whatever, all the edges are presumed or assumed to be the same length. That's why the word regular was used. If the edges are not same length, then we call it irregular. Okay, so if we know that the inside angles are all 108 degrees for a regular pentagon, it then makes sense to be able to work out what this y will be. So this is 108, 108, 108. Now 3 lots of 108 gives us 324. So that gives us 324 degrees. So to find this y, because these 3 lots and this y is angles around the point, we do 360 take away 324 degrees, and our answer becomes 36 degrees for y. So our y here is 36 degrees. So that's one way to work out the exterior angle, and another way, and the same way to work out the interior angle. Now, another way we could do this is to know the number of triangles in this pentagon. Every polygon in the world, to know the number of triangles in them, we just need to take away 2 from the number of sides. So I'll write that down. Take away 2 from the number of sides. Take away 2. Now, to find the number of triangles, I know 5 sides, take away 2 is 3 triangles. So I should have 3 triangles for a pentagon. Okay? So if we're going to have 3 triangles, how do we show that on the screen here? Always draw it from a particular vertex, a straight line. Draw your straight line from a particular vertex, just one. And you can clearly see that's 3 triangles there. I'm going to use a different color pen. Okay, so you have 1, and then you have 2, and then you have 3 triangles. Now, each is 180 for the whole angle inside. 180 for the whole angles inside. 180 for the whole angles inside each of the triangles, degrees. So 3 lots of 180 tells us that the angles inside the pentagon should all add up to 540 degrees. Now, if the whole angles inside this pentagon adds up to 540 degrees, it makes sense to work out what each one will be. So I could then do 540 degrees divided by 5 sides, because there are 5 angles inside, and I'll end up having 108 degrees for each one here. So here will be 108 here for each one here. So this is 108 in each of the 5 angles inside will be 108. Okay, remember this 180 is the whole thing inside one triangle, but each angle in the pentagon, as in 1, 2, 3, 4, 5, is 108, and that is exactly the same thing as each one we had here. So once you know that each one inside is 108, you can work out the exterior by taking the 108 from 180, and you get the exterior as 72 degrees, just like we had here. So whichever way you want to go about it, you still end up having the same thing. So, but don't forget to find the number of triangles in any polygon in the world. You take away 2 from the number of sides of that polygon, from the number or from the side number, or from the number of sides. Okay, let's just cross that off. Number of sides of the polygon. I'm just going to put that as polygon instead of the polygon, so you just know you have that note there. Okay, so take away 2 from the number of sides of polygon to find out the number of triangles. So in this case, 5 taken away 2 gives us 3 triangles. So the sum of the interior angles inside is 540 degrees for the sum of the interior angles. The sum of interior angles for a pentagon in this case. Yeah, so the sum of the interior is 540 degrees, and each one is 108 degrees, as you can see. And obviously the exterior is 72 because the exterior angles of any polygon in the world should add up to 360 degrees. Hopefully this will help us all. Thank you.